Warahmatullahi Wabarakatuh. Today I would like to present about mini project for my subject Computer Aided Programming Manufacturing CAPM. My name is Cik Muhammad YUSRIZAL AIZAL bin Cik Muhammad YUSOFF and my partner is Muhammad Raziq bin Abdul Jalil. Our content for presentation today: first is theoretical performance, second simulation model, third problem analysis and improvement, fourth new manufacturing plan, and the last one is conclusion. For operation process chart: first, machine 1 2 minutes, machine 2 take 1.5 minutes, hot process which is machine 3 take 2 minutes, cool down take 10 minutes, machine 5 inspection take 1 minute, machine assembly which is machine 6 take 2.5 minutes, for assembly machine 7 take 3 minutes, for cool down take 10 minutes, and the last one for packaging take 1.5 minutes. Now you can see our table for cycle time of machine. Machine 1 is 33.66 minutes, machine 2 33.12 minutes, machine 3 33.66 minutes, assembly 1 4 minutes, check 1 2.5 minutes, assembly 2 4.5 minutes, for pack 3 minutes. Next is production time. For machine 1, 14.23 part per hour, for machine 2, 14.47 part per hour, for machine 3, 14.23 parts per hour, assembly 1 120 parts per hour, check 1 192 parts per hour, assembly 2 106.67 parts per hour, for pack 160 parts per hour. Next is for theoretical parameter, first line production rate. To determine the line production rate, we need to find the slowest machine or workstation in the line. The slowest machine is assembly 2 with a cycle time of 4.5 minutes. This means the line can only produce 106.67 parts per hour. Next, the bottleneck machine. The bottleneck machine are the ones with the lowest production rate, which is assembly 2 with a production rate of 106.67 parts per hour. Next, for daily good and not good product yield. First, PF production rate is 113.84 parts per day. For rejection rate, 5.69 parts per day. For PD, production rate is 113.84 parts per day, and also for rejection rate is 5.69 parts per day. Next, for monthly output and good product. For PF, production rate 113.84 parts per day and 9,107.2 parts per month. For PD, production rate 113.84 parts per day and for month 9,107.2 parts per month. Next is our table, which is calculated versus simulated production rate. Now you can see our calculated production rate different with simulated production rate. For machine 1, 14.23 parts per hour, and for simulated 1.62 parts per hour. For machine 2, 14.47 parts per hour, For simulated 1.74 parts per hour. For calculated production rate, machine 3 14.23 parts per hour, and for simulated 1.68 parts per hour. For assembly 1, 120 parts per hour. For simulated 3.3 parts per hour. For check 1, 192 parts per hour and 1.68 parts for simulated. 106.67 for calculated for assembly 2 and simulated 3.78 parts per hour. For pack 1, 160 parts per hour and for simulated 4.44 parts per hour. Problem analysis and improvement. First, minimize idle time. Reduce the waiting time between raw material arrival to keep machines busy and improve efficiency. Second, address machine failures and an extra assembly to machine to share the workload and minimize disruptions caused by frequent machine breakdowns. Third, increase machine usage. Optimize task scheduling to ensure machines are consistently utilized, leading to higher productivities and output. The last one, monitor and improve. Continuously evaluate the system performance, making necessary adjustments to further enhance efficiency and productivity. That's all from me. We continue to Raziq.
So now for the model improvement, the first improvement made is decreasing inter-arrival time, IAT, for all sources. The decreased IAT minimize idle time for each source. It produces faster raw material and reduce delay while optimizing the system efficiency. It also shortens the interval between material arrivals, enabling a continuous production process. It produces a steady flow of work and increased raw material throughput. So overall production output is improved. The second improvement is the addition of a second assembly tool machine. The addition of a second assembly tool machine is to address frequent failures and repairs. Workload distribution between two machines reduce potential bottlenecks from a single machine failure. Redundancy allowed the production line to continue with minimal disruption during machine failures. Increased capacity and reliability of assembly tool machines. Produce higher rates production and for assembly tool and pack machine. Overall output yields significantly improve. New model layout, which includes the addition of a second assembly tool machine. Conclusion, IAT reduction and second assembly tool machine addresses idle time, failures and low utilization. Second assembly tool machine stabilizes production and increase rates. Workload distribution reduce bottlenecks, improving output yields. IAT reduction minimize idle time, optimizing efficiency and raw material throughput. Task scheduling optimization maximize machine activities, improving overall efficiency. Successful implementation demonstrated strategic problem solving and laid the foundation for growth. That is all for our project. Thank you.